Alright, mathematicians, let's get started with Chapter 11, Section 1, Circumference and Arc Length. Our objectives are to use the formula for circumference, use the arc lengths to find measures, solve real-life problems, measure angles in radians, and our essential question, how can you find the length of a circular arc? First, core concept is a circumference. We know this from previous course studies, so the distance around the circle. The circumference C of a circle is equal to pi times the diameter, or d, or simply circumference is equal to 2 times pi times the radius. D is the diameter of the circle and r is the radius of the circle. To get a better understanding of where pi comes from, think of it as the number of sides of a regular polygon inscribed in a circle increases. The polygon approximates the circle and the ratio of the perimeter of the polygon to the diameter of the circle, which approaches the value 3.141519, and the ... means it keeps going without ever repeating. You do not need to write any of this part down. It's just for context of how we get the value of pi. Alright, so let's use the formula to find circumference of a circle with a radius of 9 centimeters. Since we're given radius, let's use the version c equals 2 times pi times r. Then substitute 9 for the radius, or r. We can multiply the 2 and the 9 to get 18. And if we were looking for an exact answer, we would leave it as 18 pi centimeters. Or we could type it in the calculator and approximate to the thousandths place, getting 56.549 centimeters. Make sure that when you're approximating the values involving pi, use the pi key on your calculator. We no longer use the decimal value 3.14. Now we can do exact by using our pi key on our calculator. For the next one, we want to know the radius, knowing that the circumference is 26 meters. So we'll use the same formula, c equals 2 times pi times r, substituting 26 for c. We want to get r by itself, so we can actually divide both sides by all of the 2 and the pi together. And the 2 pi would divide out on the right side, which is why we don't see it anymore, to be 1. And then on the left side, we have 26 divided by 2 pi, which would simplify to 13 divided by pi, which would be our exact value. Type it in the calculator and get an approximate value of 4.138 meters. Don't forget your units. Next, let's learn about the arc length. It's a portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. This is a very important new vocabulary word. We've dealt with arc measure. Key word here is measure in our previous unit involving circles, and it's always measured in degrees. Arc's measure is in degrees. And now we're being introduced to a new concept, which is the length of an arc, which is going to be measured in linear units, for example, centimeters, meters, inches, etc. It's still the part of the circle, but this time it's part of the circumference and not the degrees of a circle. Very important difference. One way to find the arc length is to divide the arc length of, in this case, AB, but it could be any arc, major or minor, divided by circumference, which is 2 pi r. And that makes sense because we know that it is part of the entire circle's circumference. So this is a ratio, arc length divided by circumference. And we make it equal to another ratio, therefore a proportion, and that's the measure of arc AB, which remember is equal to the central angle. So whatever the central angle is the same as the arc measure out of a total 360 degrees. And if you multiply both sides by 2 pi r, you get a simplified formula. So anytime you want the arc length of a circle, in this case AB, you can always take the measure of arc AB, or any arc, divided by 360 times circumference, or 2 pi r. All right, let's check out these three examples. For the first one, we want to find the arc length of AB. So let's first set up our equation. So we'll use the arc length of AB equals 60, which is the measure of arc AB, divided by the whole measure, which is 360, times circumference, which is 2 pi r. In place of r, we'll put 8. We work that all out to be approximately 8.378 centimeters. All right, the next one, we want the circumference of circle Z. Since we want the circumference, we would use the first formula option where it's a proportion. So the arc length of, in this case, xy divided by c, our circumference, equal to the measure of arc xy divided by 360. Substitute all the values we know. We know the arc length is 4.19 inches divided by circumference c, which is unknown, equals measure of arc xy, which is 40 degrees, divided by whole circle 360. Anytime you can simplify your fractions, that's always helpful. So 40 divided by 360 simplifies to 1/9. Then you can cross multiply, resulting in a circumference of 37.71 inches. All right, our third example, we want the measure of arc RS. Using the same formula, we'll set up the proportion, so arc length of RS divided by 2 pi r equals the measure of arc RS divided by 360. Substitute all the values we know, so we know 44 is the arc length of RS, and then we know that the radius is 15.28. We do not know the measure of arc RS, so that's left unknown, divided by 360. So here we can just multiply both sides by 360, resulting in the measure of arc S to be 164.988 degrees. Make sure you include units, which is also the degree symbols. All right, let's go to a real-life problem using circumference to find distance traveled. The dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? A revolution is one complete turn with contact to the ground. We have all the different values in the diagram. So first, let's find out the diameter. And our diameter is going to be 15, which is the full diameter of the rim. And we have that labeled right over here. So the full diameter of the rim is 15 plus 2 lengths of 5.5 for the tire. All that coming out to be a full diameter of 26 inches from top to bottom of our tire. This will now allow us to figure out the circumference because we can use pi times diameter. So take pi times 26. The exact answer would be 26 pi inches. So let's think about how we would figure out the distance traveled. We know the distance traveled is going to be equal to the number of revolutions, so the number of times that the tire rotates, times the circumference, because one full rotation would be one circumference of the tire. By substitution, 15 revolutions times 26 pi would be equal to approximately 1,225.221 inches. Now, since our question's asking to the nearest foot, we're going to have to do a unit analysis. In other words, we need to change 1,225.2 inches to feet. So you set up your ratio starting with the value that you're wanting to convert. In this case, we want to convert 1,225.221 inches. And we know that there's 1 foot per 12 inches. And you want your inches to be in a diagonal position from each other so that you can cross out common units between the numerator and denominator. So in other words, if I put this over 1, the 1,225.221 inches is in the numerator, being multiplied times 1 divided by 12, 1 foot divided by 12 inches. We cross out the inches, and now we just multiply the numbers and simplify our values. So 1,225.221 ultimately gets divided by 12, resulting in 102.102 feet. So the tire travels approximately 102 feet. Alright, our final example, let's use arc length to find distances. So the curves at the ends of the track shown are 180-degree arcs of circles. The radius of the arc for a runner on the red path shown is 36.8 meters. About how far does this runner travel to go once around the track? Round to the nearest tenth of a meter. So let's think about this situation and what we're trying to find out. We know that the total distance around the track is going to be equal to 2 lengths of each straight section. And by straight section, we're talking about this piece here and this piece here that's marked by the length 84.39 meters. So there's 2 of those lengths plus 2 lengths of each semicircle. So we have a 1 semicircle here and a second semicircle here. So the first part of this equation would be 2 of the 84.39 lengths. The second part of our equation would be 2 of our half circles. So if we had 1/2 times 2 pi times 36.8 being our radius, so 2 half circumferences, and the half and the 2 is going to multiply to be 1, so you end up with 36.8 pi times 2. And that all simplifies to approximately 400.001. So the runner on the red path travels about 400 meters. Alright, our final concept to understand in this section is measuring angles in radians. First of all, radians are a unit of angle equal to an angle at the center of a circle whose arc is equal in length to the radius. So what we need to know is how to convert from degrees to radians and vice versa, radians to degrees. Well, for degrees to radians, simply multiply the degree measure that you're wanting to convert by either 2 pi radians divided by 360 or radians divided by 180 degrees. One correction, that should be pi radians divided by 180 degrees. And then for radians to degrees, you flip those fractions. You multiply the radian measure that you're wanting to convert by either 360 divided by 2 pi radians or 180 degrees divided by pi radians. Alright, so let's take a look at 2 examples to practice converting from radians to degrees and vice versa. So first we're converting 45 degrees, so degrees to radians. So take your 45, what you're trying to convert, and multiply by pi radians divided by 180 degrees. And that simplifies to pi divided by 4. And you must include that word radian. It's kind of like you have to include the word degrees. So 45 degrees equals pi divided by 4 radian. Now let's convert 3 pi divided by 2 radian to degrees. Since that's what we're trying to convert, you start with that and multiply it by 180 divided by pi radians. And that all works out and simplifies to 270 degrees. So 3 pi divided by 2 radians is equal to 270 degrees. So I leave you with this magnificent structure of a circular building built in China. So kind of a cool fact. All right, see you in class.